Hi, Anthony Carruthers, Better Lesson, Master Teacher Project. And in this particular video, I basically do want to demonstrate some of the bookkeeping techniques that I model for students when we're doing this handout. So in this section of the handout, students are asked basically to identify the sides that are shared between two triangles. So for example, we can see that segment CD is shared between two similar triangles. And the two triangles that it is shared by are the smaller triangle, or the smallest triangle, and then the medium-sized triangle. So I'll just name the first triangle arbitrarily. So we'll call it triangle ACD. Okay, but then I want to pause for students and have them see that now that we've specified the order ACD, we'll need to know which vertices or which angle measures correspond to vertices A, C, and D. So, for example, A corresponds to theta, C has an angle measure of 90 minus theta, and D has a right angle. Okay, so we'll want to be careful then when we name the other triangle that we keep that same order. So I'll look in triangle CDB for the vertex that has theta as the angle measure, and that would be vertex C. So C should come first in the same way that A came first. Then I'll want to look for the angle that has a measure 90 minus theta, and in this triangle that would be at vertex B. And then of course the right triangle in this triangle is at vertex D. Okay, so in that way I've named these two triangles so that their corresponding vertices are in the same order. So just taking that as an example, we move to the next part of the handout. And for segment CD, which we've done the work for here, the associated similarity statement would be that triangle ACD, and again order matters, so triangle ACD is similar to triangle CBD. Now the serious bookkeeping comes in when we figure out how to make the proportion. This is where students sometimes struggle. So I'll want to focus on segment CD. So the technique I share with students is to first look in the first triangle and find segment CD within that triangle. So notice I've underlined segment CD in the triangle. Then, since I've underlined there the second and third positions, I'll want to underline the corresponding positions in the other triangle. So I'm going to underline BD. So what we've just established is that CD corresponds to BD. So that'll be one part of the proportion. So it's going to equal something over something. All right. In the geometric mean, we know that CD is going to appear twice. That was the basis for finding the shared sides. So now I want to look in the second triangle and see where segment CD shows up in that triangle. So I'm going to notate that with some kind of different symbol. So in this case, I'm going to use kind of an arc between C and D. And we can see here that I've basically made an arc from the first position to the third position. So to do the corresponding thing in the first triangle, I'd also have to go from the first position to the third position. So in that way, I can see that segment AD, or the length of segment AD in the first triangle, corresponds to CD in the second triangle. So by doing that type of bookkeeping, now we have our proportion. Okay, as we planned it out, we see that CD appears twice in the proportion. So now we can see from this structure that CD is the geometric mean of BD and AD. Okay, so again, so that's just some of the kind of bookkeeping organization strategies that I share with students, so that making these proportions and identifying the geometric means is a little bit easier.